There's a lot of information out there linking manifestation to quantum physics, and it can get quite confusing. Today I'm going to give you the clearest and quickest summary of how the law of attraction relates to quantum physics, so by the end of this video you'll have a complete understanding and no misconceptions. Hi everyone, my name's Georgia. I just finished studying a master's degree in consciousness, spirituality and transpersonal psychology, and in my free time I love to study the links between science and spirituality. Now, I've spent a lot of time researching the links between quantum physics and the law of attraction, specifically trying to understand where the correlations come from and where they sometimes might be misrepresented. In this video, I'm going to give you a crash course in the experiment at the heart of this connection and explain how it might relate to manifestation. So the reason the law of attraction is often related to quantum physics is because of an experiment called the double-slit experiment. Now, the way this experiment is set up is as follows. Basically, we have a wall that has two slits in, and behind that wall we have a screen that is able to capture particles. Now, what scientists do is they fire particles like electrons at the wall that has two slits in. Now, what we would logically expect to happen is that each particle would go through either one of the two slits and form two clusters on the back screen directly opposite those two slits. But something unexpected happens. Instead of seeing two clusters on the back screen, we actually see an interference pattern, as if a wave had gone through both of the slits at once and interfered with itself on the other side. Interestingly, this wave-like interference pattern still occurs even when we send the particles through one at a time, so it's not the result of particles bouncing off of each other. To investigate this further, scientists placed detectors at the slits to try and observe which slits the particles were going through. But when they observe the particles, something interesting happens. The interference pattern vanishes and the particles start acting as if they have gone through only one of the slits. So we get the two clusters on the screen as we would have expected in the first place. So it appears that the act of observing or measuring changes the behaviour of the particles, almost like reality isn't decided until we interact with it in some way. So here's what we know so far. When observed, quantum particles act like particles. They go through one of the two slits and cause two clusters to form on the back screen. But when not observed, these quantum particles seem to behave like waves, as if they're going through both of the slits at once and interfering with themselves to create an interference pattern. Whether they're literally going through both slits at once is up for debate, but there is a concept in quantum physics called superposition, which allows for a particle's position to remain undetermined until it is measured. It exists as a probability wave encompassing all possibilities. So in this case, that would be going through only slit A, also going through only slit B, but also going through both slits at the same time. Keep this idea in mind for how all of this relates to manifestation, specifically the idea that all potential realities might already exist in some sense. Now, before we go any further, there are two important clarifications that we need to make. The first one is that we don't actually know that these quantum particles are in a wave state when we're not observing. This is because when we measure them, they act like particles again, so we're left uncertain about the state that they're in when we're not measuring them. Physicists use something called a wave function to describe the behaviour of the particle when we're not looking at it. So the wave function is a mathematical tool, and some physicists believe it is just that. It's nothing more than a mathematical tool that allows us to assign probabilities as to where we might find that particle. It also allows us to assign probabilities to other properties of the particle as well. But other physicists do believe that the wave function might actually represent a real physical wave. Basically, no one knows, and the Copenhagen interpretation, which is one of the leading interpretations of quantum physics, even says it's completely pointless to ask what's going on when we're not observing. Now, the second important clarification is that in quantum physics, observation means measurement. In this experiment, it is the act of measuring or interacting with the particle which changes its behaviour. Where human consciousness comes into play is in a particular interpretation of this experiment, which we'll explore next. So how does all of this connect to manifestation? The double-slit experiment suggests that reality might not be as fixed as we originally thought. Observing or measuring particles changes their behaviour, which raises questions as to whether consciousness might have any effect or influence on this process. According to the von Neumann-Wigner interpretation, it is consciousness itself that causes particles to shift from their wave-like state or superposition of possibilities to being in a fixed particle state. If this interpretation is true, then it could mean that our focus, attention, and intention could play a role in shaping our reality. Perhaps our focused thoughts could collapse possibilities into reality, similar to how particles take on a definite position when they're measured. Think back to the concept of superposition. A particle exists in all possible states until it is measured. In a similar way, maybe we can select a reality from multiple possibilities through our focus. So in short, quantum physics, through experiments like the double-slit experiment, suggests that reality might be more fluid than we once thought. Whether consciousness has any influence on these mysterious processes that are happening at the quantum level is entirely speculative, but it certainly offers some interesting correlations to the law of attraction. If you enjoyed this video, please give it a thumbs up, and if you want to explore this topic further, then you can watch this video in which I go much more in depth into this topic and how interpretations of quantum physics relate to manifestation. Thank you for watching.